Today we get to learn about one of my absolutely favorite things ever in algebra, and that is the quadratic formula. So just like we learned how to solve quadratic equations by factoring, by completing the square, the quadratic formula is another method that we can use to solve these types of equations. And just as a reminder, when I say solve quadratic equations, what am I really asking for? I'm asking you to find the x-intercepts. I'm asking you to find those points where the parabola hits the x-axis. What else can we call the x-intercepts? Also known as, aka, the zeros. And then we also learned a third thing we can refer to x-intercepts as roots. So if I say find the x-intercepts, find the zeros, or find the roots, I'm asking for the same thing. They all mean the same thing. So what is the quadratic formula? The quadratic formula is as follows. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the quadratic formula is a formula that we can use to find what x is equal to. You always have to have an x equals in front of your work. Otherwise, I'm not going to give you credit, and you're not finding x then. So where does b, a, and c all come from? Well, you should recall that quadratic functions are in standard form look like y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. So all you're doing is you're taking a, that coefficient of x squared, and plugging it into the formula here and here. You're taking the coefficient of x, b, and you're plugging it into the formula here and here. And then c is your constant. C is your constant, and that's getting plugged into the formula here. So we're just taking a, b, and c from ax squared plus bx plus c, and we're plugging it into this little formula. So that formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you were in class with me in person, I would pause the lesson here and then have you guys actually just practice reading this formula out loud. So if you would just humor me and read this formula out loud with me, just practice saying it out loud. Let's say it together. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's a couple things I need you to notice about this formula. The square root sign needs to go all the way across the b squared minus 4ac. You're taking the square root of all of that, and your division sign, your fraction bar here, the all over part, needs to go all the way under the negative b plus or minus as well as the square root. So that way we divide all of that by the 2a, or 2 times a. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this formula helps us find the x values, what x is equal to for these 2 points, our x-intercepts, our roots, our zeros. So for the first example that we're going to apply this to, I've given you the equation 5 equals 2x squared minus 3x. So just like usual, we need to make sure that this equation is equal to 0. Right now it's equal to 5. So we're going to make it equal to 0 by subtracting 5 to both sides. So 5 minus 5 is 0 equals 2x squared minus 3x minus 5. Since this negative 5 is not a like term with the 2x squared or the negative 3x, we just write it off at the end, and we can't combine it with anything. Well, now this equation is in standard form, ax squared plus bx plus c. Now I can tell exactly what a, b, and c are. So remember, a is the coefficient of x squared, b is the coefficient of x, and c is your constant. So the first thing you want to do when you use the quadratic formula is identify a, b, and c. So a in this case, a in this case is 2, b is -3, and c is -5. So now that we have identified a, b, and c, we're ready to set up the quadratic formula. So I'm just going to write the quadratic formula to remind me what it is. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to fill it in using 2 for a, -3 for b, and c for -5 for c. So we're going to have x equals the negative of b. So we're taking the negative of -3 plus or minus the square root of -3 squared minus 4 times a is 2 and c is -5. All over 2 times a, which is 2. So notice I replaced a with 2. I replaced c with -5. And I replaced b with -3. There's a couple other things I need you to notice as well. And that is, we have to take the negative of b. So I made sure to put b in parentheses. And then when I square b, I also made sure to put b in parentheses because b is a -3 and we need to square that -3. So we need to take -3 squared. All right, in the last step, so we're actually going to go ahead and simplify that equation. So we're going to simplify x equals the negative of -3 plus or minus the square root of -3 squared minus 4 times 2 times -5 all over 2 times 2. So x is equal to the negative of -3 is +3 plus or minus the square root of -3 squared is -3 times -3, which is +9. And then -4 times 2 times -5 is -4 times 2 is -8. -8 times -5 is +40. All over 2 times 2. Notice at each step I'm keeping x equals out in front because we're trying to solve for x. We're trying to find our x values of our x-intercepts, our zeros, our roots. So we're going to keep that x equals out in front at every single step. X equals, now what can we simplify next? Under this radical, I have 9 plus 40. 9 plus 40 is 49, all over 4. I'm going to come up here. X is equal to 3 plus or minus. Now we can square root 49. What's the square root of 49? 7. So notice here, how many answers do we actually have? Just like when we solved by completing the square, because we have this plus or minus, that means we have 2 answers, which we normally get 2 answers when we solve these equations, right? When we solve by factoring, when we solve by completing the square, we've always gotten 2 solutions. The quadratic formula also gives us 2 solutions because of that plus or minus. So I'm going to split those 2 answers. I'm going to have x is equal to 3 plus 7 over 4, and x is equal to 3 minus 7 over 4. And yes, you do have to split it. This right here is not your final answer because this fraction can be multiplied. So we want to make sure that we simplify these fractions. So x is equal to 3 plus 7 over 4. X is equal to 3 plus 7 is 10. 10 over 4. That simplifies to 5/2. X is equal to 3 minus 7 over 4. That would be negative 4 over 4, which is x is equal to negative 1. So then our answer is x equals 5/2 and negative 1. And we have our two solutions. So if we graphed this parabola, we would see it cross the x-axis at x equals 5/2 and x equals negative 1. So why don't you go ahead, press pause on this video, and just attempt to do example 2 without me. See if you can get it started. See if you can get that quadratic formula set up correctly. See if you can identify A, B, and C correctly, and at least try to start to simplify the formula. When you're ready to check your work, hit play, and we will do it together. So in example 2, you have the equation 0 equals x squared plus 4x plus 3. A would then be equal to 1, B is 4, and C is 3. So let's set up our quadratic formula. X is equal to the negative of 4 plus or minus the square root of 4 squared minus 4 times A times C, all over 2 times A, or in this case 2 times 1. So x is equal to negative 4 plus or minus 4 squared is 16. Negative 4 times 1 is negative 4, times 3 is negative 12. Watch out for those signs. All over 2 times 1, which is 2. X is equal to negative 4 plus or minus the square root of 16 minus 12 is 4, all over 2. So x is equal to negative 4 plus or minus the square root of 4 is 2, all over 2. So x is equal to negative 4 plus or minus 2 over 2. That's as simplified as that can get for now. But remember, how many answers do we have here? We have 2. So we need to split this up. So x is equal to negative 4 plus 2 over 2. And x is equal to negative 4 minus 2 over 2. So we can get both of those solutions. X is equal to negative 4 plus 2 is negative 2 over 2. X is equal to negative 4 minus 2 is negative 6 over 2. Negative 2 divided by 2 is negative 1. And negative 6 divided by 2 is negative 3. So x is equal to 1 and negative 3. So where would we see these, this parabola hit the x-axis? We would see it at x is 1 and x is negative 3. So let's do the same thing with example 3. Give it a shot without me, and then press play when you're ready to check your work. Okay, so I went ahead and just set up the problem for us so we could talk our way through it. The first thing I did was I identified A, B, and C. A is 2, B is negative 3, and C is 7. Then I plugged those values into my quadratic formula. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I simplify this. The negative of negative 3 is 3. Negative 3 squared is 9. Negative 4 times 2 times 7 is negative 56. Now, as you were simplifying your work, I bet you ran into a problem here because 9 minus 56 is negative 47. Uh-oh, we have a negative under our radical. Do we know how to deal with negatives under radicals? So far, what we've learned is that when you square root a negative, you get no solution. It's impossible to square root a negative. Well, later on in this unit, we're going to learn how to deal with negatives under radicals. And what you actually will find out is that whenever you have a negative under a square root, you get an imaginary answer. So this is going to give us what we call an imaginary 0. And you haven't learned about that yet. So for now, if you run into a problem like this, you can tell me that you are going to get imaginary zeros. Or you could also say you're going to get non-real x-intercepts. And the reason why is because if you went to Desmos real quick, desmos.com, and you typed in the equation y equals 2x squared minus 3x plus 7, if you graphed this original equation, you would see, this is just a super rough sketch, that the graph is actually above the x-axis. So here's the x-axis, here's the y-axis. This parabola is somewhere up here. Does this parabola actually hit the x-axis on the real number line? It doesn't. So that's why we have non-real x-intercepts, or imaginary zeros. What we're eventually going to have to do is add in an imaginary number plane, and the x-intercepts exist on that imaginary plane, but they don't exist on the real number plane, because when you square root a negative, you don't get a real number. You get an imaginary number. But we'll talk more about that later. I just wanted to expose you guys to what it looks like when that happens. So that's all for today. On Thursday, we're going to do solving using the quadratic formula part 2.